A system can be either closed or open. A closed system is a system that is completely isolated from its environment. This is the definition commonly used in the system literature, which we have chosen to follow. This is different from the thermodynamics definition, which differentiates between systems that are closed, no material flow, and isolated, no material or energy flow. The physical universe, as we currently understand it, appears to be a closed system. An open system is a system that has flows of information, energy, and/or matter between the system and its environment, and which adapts to the exchange. This is a fundamental science definition. It differs from the meaning of open system in IT and related fields, where the term is used in the sense of open system architecture that allows for a vendor-dependent, non-proprietary computer system or device design based on official and/or popular standards. All physical systems of interest to systems engineering are open systems. However, there can be special cases in systems engineering where it is convenient to treat a system as if it is closed, if there are no significant external relationships or interactions to contend with. Entropy increases in a closed system. In open systems, the entropy is kept low, or decreases, essentially at the expense of entropy increasing somewhere else, so the entropy of the universe continues to increase. Thus, systems tend to maintain their organization at the expense of increased disorder elsewhere, which is a common cause of unintended consequences. It follows that a more fundamental definition of system could be a persistent region of low entropy equals high organization in physical or conceptual spacetime. Thus, then, it would follow that systemness is the phenomenon that allows regions of organization to persist in a dissipative universe. We now introduce our preferred terminology to distinguish between naturally occurring and human-made systems, while noting that many systems are a hybrid of the two, so this is not a binary classification. A natural system is a system that occurs in nature without intervention by human agents. Natural systems exhibit properties such as viability, resilience, and self-organization that offer exemplars for engineered systems. Biomimicry refers to the practice of using natural systems as patterns for artificial ones. An artificial system is a system constructed by human agents, or otherwise caused by them to come into being. Human agents can be beings, or they can be processes, methods, or tools created by humans that affect change indirectly to create the artificial system. A hybrid system is a system with both natural and artificial elements, or a natural system influenced, e.g. by selective breeding, or modified, e.g. by genetic engineering, by intentional agents. An engineered system means a system, artificial or hybrid, conceptual and/or physical, that was properly systems engineered in the sense of the definition. Otherwise, a human-made system is artificial or hybrid but not engineered. Of course, there can be the case of a badly engineered system, such as a system where the operational environment is not well anticipated and the applicable constraints poorly selected.
Sounds like a shitty game.
Some authorities maintain that there are three kinds of system: natural, social, and artificial. In this viewpoint, a social system is any system made up primarily of intentional agents, which is not driven by natural forces but rather the force of willpower and cunning and various other intentional qualities, while an artificial system is one composed of deliberately created artifacts. The term human activity systems is often used for social systems where the intentional agents are humans. Groups of agents working to a common purpose are not unique to humans. Many animals live in social systems, and there is a spectrum of social systems, ranging from those composed of humans where the social system is deliberately constructed and maintained, and can adapt rapidly, to simpler ones, such as ant colonies, where the intentional behavior appears to be hardwired in genetic material. Systems engineering takes place within a social system and typically produces part or all of a socio-technical system, a system with closely coupled social and technical parts. There are many definitions in the literature for these and related system types. We do not attempt to offer firm definitions for these categories.